Hello everyone, we're back again for the next part of the chemistry revision for grade 8. Previously we went through the acids and alkalis and the differences between them and using the indicators and all those things. As for now, we're going to go through the neutralization. Okay, the neutralization here, the term neutralized, more likely is like it's not an acid, either like not even an alkali. So water is the best example for a neutral solution, but the process of neutralization, it's more likely, it's like when you have something too acidic or too alkali and you try to make it like up to the optimum of neutralization. As we know, or actually it's sort of a rule you go through, it's like when you add acid to an alkali, they both cancel each other. So for an example, if you got something too acidic and you want it to be acceptable, you just keep adding alkali, because when you add alkali, it doesn't go alkali, it's just kind of like reaching the point of both of them are cancelled and you have a neutralized solution. For an example here, like a bee sting, are actually acidic and they are treated by neutralizing the acid with a mild alkali like bicarbonate of soda. Meanwhile, the wasp sting are slightly alkali and treated by neutralizing with an acid like vinegar. Therefore, it's important for you to know. Okay. Mixing acids and alkalis. As we add an alkali to an acid, the molecules in the acid and the alkali react. The resulting solution here becomes less acidic. The pH increases as we add more alkali. It's almost as if the alkali cancels out the acid. So this is called a neutralization. So neutralization is actually the process or the reaction of the acids with alkalis. So if we just add the right amount of alkali, the solution will become exactly neutral. Neutralization in action. There are examples of neutralization reaction all around us. Like for an example, our saliva, which is here inside of our mouth. It's actually alkali and it neutralizes some of the acid that is made by the bacteria in our mouth. We also neutralize the acid by using a toothpaste. The toothpastes are alkali. The heartburn, which is caused from this acid from the stomach, we use anti-acid tablets that contain an alkali that neutralizes the acid, and we feel much relieved after we take them, like Gaviscon or Renin, the tablets. Industries as well, like textile and paper factories, produce a lot of alkali liquid waste. This is neutralized with acid before it's disposed. How do we actually make a neutralized solution? Like for an example, I'm going to use a burette and a diluted acid with a conical flask with a diluted alkali here and a universal indicator. I open here from the tap, from here, and I just keep dropping, like drop by drop. Here we've got a universal indicator and we've got an alkali, so practically here it's a bit bluish, and I keep adding the acid drop by drop, and the universal indicator here like tells me when to stop. When it starts changing the color and the color here is like turning to be like almost green, then I stop and I know that I had a neutralized solution. Okay. Understanding salts. The salt here is made in neutralization reaction. So when I have an alkali reacting with an acid, one of the products is actually a salt in addition to water. A salt here is made in neutralization reaction along with the water. The most common salt is sodium chloride, the one that we use in which is salt that we add into our food. It's used for flavoring the food, treating icy roads, and as a food preservative. So, the salt here has many uses: flavoring food, treating icy roads and as a preservative. Sodium chloride is essential also in a human body and in industry. The sodium chloride is producing chlorine, hydrogen and sodium hydroxide, and each of these have its own important uses. The magnesium chloride is used in the manufacture of the cement. And iron sulfate is used by gardeners to kill the moss on the lawns, and calcium sulfate is used to make plaster of Paris to treat the fractures. This is plaster of Paris, the one when they have like a broken leg or an arm. Okay, the salt made during a neutralization reaction can be predicted, like the first part of the name of the salt comes from the alkali, and usually from the metal in the alkali. For an example, we've got sodium hydroxide. Forms salts that start with sodium, where magnesium hydroxide salts start with magnesium. And the second part of the name comes from the acid. Like here. The acid used in neutralization, for an example, hydrochloric acid. So it forms a chloride. Sulfuric acid forms a sulfate, and nitric acid forms a nitrate. A base is any substance that neutralizes an acid to produce salt and water. An alkali is a soluble base that dissolves in water. Therefore, this is an important point, all alkalis are bases, but not all bases are alkalis. Copper oxide is an example of base. Sodium hydroxide, is an example of a base that is also an alkali. Exploring the reactions of acids with metals. Most metals react with acids. The way that a metal reacts varies and depends on its reactivity. Some metals are so reactive that you would never add some acids to them in the lab. Okay, the chemical reaction is one of the in which new products are made. Like for an example, you would have bubbles of some sort of those bubbly appearance that predicts or tells you that you've got a gas being given off. A change in the temperature could be exo or endothermic, a color change, and a change in the mass. Okay. What are the new products? Acid here reacts with most of the metals. Just like when acid reacts with an alkali, a salt is formed. However, water is not formed. It's not like neutralization. Instead, a gas is formed, which is hydrogen. So acids, when they actually react with metals, a gas is formed. You can test for hydrogen, which normally the gas that we have as a product is hydrogen. I can test hydrogen gas because it burns with a pop. It's like it has that sort of a pop sound when it's formed. If you put a lighted splint into the top of the test tube, which an acid and a metal are reacting, you will hear a pop sound. This is because the flame ignites the hydrogen and it explodes. Okay, this is the equation. The acid plus metal gives me salt and hydrogen, and the acid plus alkali gives me salt and water. And the salt produced depends on the type of acid and the type of metal. Like, for an example, if you react nitric acid with copper, you will have copper nitrate. So that's the salt, which is copper nitrate. Exploring the reactions of acid with carbonates. So, acid with a metal carbonate actually gives me salt and water, and since it's a carbonate, that means it gives me also carbon dioxide. Like for an example, limestone contain a metal which is carbonate, and limestone contain calcium carbonate specifically, and it reacts with acid in a predictable way, and it gives me new products. If an acid is mixed with a metal carbonate, fizzing is seen. You know those kind of like bubbly gases? It's more likely when you open a fizzy drink like Pepsi or 7-Up and you find out that even if you shake it a bit, or without even shaking, you will find out there's those tiny bubbles on the edge. That's a gas Okay, the gas produced when acid reacts with a metal carbonate is carbon dioxide. So you can carry out a test to prove that this is a carbon dioxide because it turns lime water cloudy. So the lime water here is actually, we use it to predict whether we have carbon dioxide or not, because carbon dioxide actually makes lime water cloudy. Carbonate reacts with an acid to produce salt and water. This reaction also makes another product, which is carbon dioxide. So the equation for this, for acid reacting with metal carbonate, is salt, water, and carbon dioxide. Like for an example here, if hydrochloric acid is reacting with calcium carbonate, the salt here is calcium chloride. But if hydrochloric acid is reacting with copper carbonate, the salt here will be copper chloride with water and carbon dioxide. When an acid and a metal carbonate react in an open container, the carbon dioxide produced escapes into the air, so the mass in the container decreases. Investigating the effectiveness of antacids. As we all know that we use antacid, which is mainly an alkali, to neutralize the acid coming out from the stomach and causing us heartburn. So heartburn in digestion is caused by acid from the stomach irritating the upper digestive tract, like for the esophagus. For those who suffer regularly, treatments are available to neutralize this acid. But the remedies are either like renin, the antacid tablets, or Gaviscon as a syrup. The human stomach here contains strong hydrochloric acid with a pH of approximately, which means nearly 1. The role of this acid is to enable digestion of proteins inside of the stomach and also to prevent many bacteria from surviving in the stomach. So these are the properties or the function of the hydrochloric acid. Sometimes the muscle leading from the esophagus to the stomach can open, because sometimes sometimes it could be genetically, and sometimes it's like you were just eating while you were laying, and it's kind of like it's not closed yet. So the acid moves up along the digestive tract, and a burning sensation is then felt in the chest and the throat as the acid irritates the lining of the esophagus. So this is what we call a heartburn or indigestion. One of the main treatments for heartburn involves neutralizing the acid from the stomach. Medicines that do that is called antacid. Antacid remedies contain substances like calcium carbonate, aluminium hydroxide, and sodium hydrogen carbonate, which is baking soda. These substances actually neutralize the acid, just like alkalis do. However, they don't dissolve in water like alkalis, so that's why they are known as bases. Bases react with acids in neutralization reaction, which is acid in addition to a base. It gives me salt and water, and practically they reduce the acidity in the stomach. And for now, we're going to stop here and continue the next part. Thank you.